So in last lecture we have discussed all 2 marks questions, 1 mark and 2 marks questions, and in this lecture we will see 3 marks questions from chapter electricity. So 63rd question, show how would you join 3 resistors each of resistance 9 ohm so that equivalent resistance of the combination is 13.5 and 6 ohm. So the question is, they have given 3 resistors of each capacity 9 ohm and we need to connect it. So if we connect, that equivalent resistance should be 13.5. Okay, now so in 2017 they asked, and there is one internal choice question. First we will solve this and then we will go with this. So 3 resistors we need to connect. So here you see one resistor here, so second resistor, third resistor of each 9 ohm, 9 here and 9 here. You see 2 resistors are in parallel, and first we need to solve this one. This system if we can solve, it is 1 by 9 plus 1 by 9 which is equal to 1 by R. LCM is 9, 1 plus 1 which is equal to 1 by R. 2 by 9 is equal to 1 by R, and if you reciprocal this 1 by R, this will be reciprocal and it becomes R is equal to 9 by 2. So 9 by 2, 2 4s 8.5, so 4.5 will get, and we have to convert this system to this one. So this resistor is there, 9 ohm resistor, that will be as usual. After solving this system, so these 2 resistors are in parallel. Now we have made one single resistor, and what is the capacity of that single resistor? That is 4.5 ohm. So this resistor 9 ohm, this is 4.5, 9 plus 4.5. Again we have to solve this system. These 2 resistors are in series, so we have to make it as single resistor, and 9 plus 4.5, that is 13.5. So like that we need to solve. So this is the diagram we have to draw. That's it. We have to draw and then we have to solve this one. Then they have asked 6 ohm. So how to do with 6 ohm resistor? So here you can observe 2 resistors are in series and 1 resistor with parallel, means like this. First resistor, second resistor, and here third resistor. So this capacity is 9 ohm, this capacity is 9 ohm, this capacity is 9 ohm. If these 2 resistors, first of all, how to solve this? We have to convert this system to this system. Means we need to solve these 2 resistors and convert to 1. 9 plus 9, 18. 18 ohm, and here as usual it will be 9 ohm. Now 2 resistors are in parallel. We have to use formula 1 by R is equal to 1 by R1 plus 1 by R2, which is equal to 1 by 18 plus 1 by 9. And LCM is 18 and 9. LCM what we can take, bigger number is 18, we can take 18, 18 ones plus 9 twos 18, that is equal to 3 by 18, 3 ones 3 6 18. So 1 by R is equal to 1 by 6. If this is reciprocal, this will be reciprocal and R becomes 6 ohm. That's what they asked in the question. And internal choice question, first question, write Joule's law of heating. So we have to write the statement or explanation for Joule's law of heating. Next, they have given data 2 bulbs, one rated 100 volt, 100 watt, 220 volt. So first bulb is 100 watt, 220 volt. Second bulb 60 watt, 220 volt are connected in parallel to electric main supply. So here there is one bulb and here there is another bulb. 2 bulbs connected in parallel to electric main supply. So if you observe these 2 bulbs, it is 220 volt like this. Find the current drawn by 2 bulbs from the line if the supply voltage is 220. So we have to find current here, we have to find current here in these 2 bulbs. So first bulb capacity is 100 watt, second bulb capacity is 60 watt. So here we have P and V, we have to find I. We know formula power, P is equal to V into I. So if you use for the first bulb power is 100 is equal to voltage value is 220 multiplied with I. We need I. So what we can do, we can send the 220 that side, it becomes 100 by 220, 0 gets cancelled, 10 by 22. So we'll try to solve that one also. And second bulb, same, P is equal to V into I. P value of the second bulb is 60, which is equal to voltage 220 multiplied with I. If you need I, send the 220 that side. So I becomes 60 upon 220. 0, 0 gets cancelled, 2 3s, 2 11s. Here also 2 5s, 2 11s. So we can multiply 5, 0 .11 4s, 44, 6.0, 11 5s, 55. It will be going on anyhow. So first bulb current I equal to 0.45 amp nearly. And second bulb I value is equal to 11 upon 3, 0.11 2s 22, 8 point is there 0, 11 7 77. It will be going on. So I2 value. So our current for the second bulb is 0.27 amp nearly. So values you can write that one. So let us try to see the answer. So Joule's law of heating. When current I is passed through resistor for some time t, heat is produced. So we know Joule's law of heating formula, H is equal to I square RT. Basically, how we got that I square RT? We know power. Power is equal to V into I. Heat is nothing but power into time. Power into time. Then we know power P is equal to V into I. If you can substitute, H is equal to V into I into T. And we know Ohm's law, V is equal to IR. If you substitute V is equal to IR here, it becomes H is equal to IR into IT. So which is equal to H is equal to I into I square RT. So what is the expression for this? What is meaning for the H is equal to I square RT? H is equal to I square RT. We don't have any denominator. Now the meaning is heat is directly proportional to square of the current. When current increases, heat energy increases. Heat directly proportional to resistance. When resistance increases, heat energy increases. Heat directly proportional to time. If time increases, then heat increases. That is Joule's law of heating. And here, if you can observe 0.45 and 0.27, which we got answer here 0.45 for the first bulb, 0.27 for second bulb. So after solving this numerical, definitely have to write I is equal to 0.27 amp, because for writing this value half mark and for writing unit half mark. Like that you need to solve that question. Next question. So ABC 3 marks question 2017. List the factors on which resistance of conductor in the shape of wire depends. B. Why are metals good conductor of electricity whereas glass is bad conductor of electricity? Give reason. C. Why are alloys commonly used in electrical heating devices? So first one, what are the factors affecting resistance? So there are 3 factors, right? So first one, resistance is directly proportional to length. Second factor, resistance is inversely proportional to area. Third one, it is and resistance depends on temperature. At last, nature of the material. So or these 2 things we can write, more than enough. Resistance directly proportional to L, resistance inversely proportional to area of cross section. Enough. Second one, why metals are good conductors of heat, but metals are good conductor of electricity whereas glass is bad conductor of electricity. Metals are good conductors due to having large number of free electrons. Here the key word is free electron. Guys, here conductor, every conductor has free electrons, and whenever potential difference is given, when potential difference is generated, when voltage is given, automatically this battery will be applying some force on the free electrons, and all free electrons will be in motion, which we are calling it as current. So in metals, there are huge number of free electrons. This is the word we have to write and try to underline that one. And their low resistivity. There will be no resistance. If there is resistance, it cannot pass current through it. Conductors will have least resistance. Try to understand that. Conductor will have least resistance. Alloys will have huge resistance. Because of least resistance, flow of current will be high. Because of high resistance in alloys, rate of current is less. In conductor, because of least resistance, current is passed very easily and heat is not generated. Heat will be less. In alloys, because of resistance, because of less amount of current, it will be opposing current, so that huge amount of heat is generated. That is the concept we have to understand. So here, C question. Alloys are commonly used in heating devices due to their high resistivity and high melting point. So this is the point you have to write, high resistivity. When resistance is high, melting point also will be high, so that they are used in heating devices. When current is given, that the heating element, that filament or the coil will oppose total charges, and resistance will be so high, then current rate will be less, heat will be more. That is the concept we have to understand. Now 65th question, 3 marks question. In 2016 they asked, VI graphs for two wires A and B as shown in figure. If both the wires are made up of same material and of equal thickness, which of the two is more length? Give justification for your answer. Okay, there is a graph. We will try to see the graph. Okay, this is a graph. Which one has more resistance? When there is you see, this is A, this is B, and A, this line is having more slope, right? This angle also greater. Here the angle is least. So if angle is greater, if there is huge slope, then this has higher resistance, and this is least one which has least resistance. Directly answer we can write for that. 66th question. What is meant by electrical resistance of a conductor? State how resistance of a conductor is affected when a low current passes through it for short duration, heavy current passes through it for about 30 seconds. Okay, electrical resistance is the property of conductor. Every conductor will have that property. And also every conductor has least resistance. Because of least resistance, it can pass total amount of current through it. Okay, so property of conductor by virtue of its opposes, which it opposes the flow of current through it. And here conductor will have least resistance, so that greater flow rate will be there. Okay, next point. It is equal to the ratio of the potential difference applied across its end to the current flowing through it. Because there is no particular definition and this one for resistance, so what we can do, we can take help of Ohm's law. What is Ohm's law? V is equal to I into R. From this, what is R? R is equal to V upon I. So from this we can define what is resistance. Resistance is ratio of potential difference applied across its end to current passing through it. So V by I, which is nothing but resistance, that is the ratio of voltage by current is nothing but resistance. Okay, they have given two conditions. State how resistance of conductor is affected when a low current passes through it for short duration. Okay, very short duration, 1 second, 2 seconds, or 3 seconds, something like that, if low current is passed. Okay, answer, when low current is passed for short duration through the conductor, heat produced is almost negligible, that is zero, and hence no applicable change in its resistance. So if you send only for 2 seconds, 3 seconds, 5 seconds, no heat is generated. Next one, if you pass heavy current and about 30 seconds, when heavy current is passed through the conductor for 30 seconds, conductor may get heated and its resistance and resistivity changes. So if you pass current for huge more time, maybe 30 seconds, 1 minute, 5 minutes, 1 or 2 hours, definitely heat is generated. But for the less duration, heat is not generated. That is the answer you have to write. 67th question. Name and define the SI unit of current. Calculate number of electrons that flow through conductor in 1 second to constitute current of 1 ampere charge. Okay, charge of an electron. This already we did it. Okay, fine. Name and define the SI unit of current. SI unit of current is ampere, which is represented with capital A. And how to define that ampere means we need formula. Current I is equal to Q upon T, means current is nothing but net charge upon time. So some bunch of electrons, some net charge is flowing in conductor in 1 second, which is nothing but current. There is S unit for current, that is ampere, which is equal to S unit for charge is coulomb, S unit for time is second. Now how to define ampere means 1 ampere of current is nothing but if 1 coulomb of charge is flowing in conductor just in 1 second. In 1 second, if 1 coulomb of charge is flowing, that is 1 ampere of current. Like that we can define. And we know how many electrons will be present, number of electrons. So already we did that one. We know Q is equal to N into E. N stands for number, Q stands for net charge, E for charge of electron. We have to find N. N is equal to Q upon E. Q value is 1 coulomb upon charge of electron is 1.6 into 10 to the power of minus 19 coulomb. Coulomb gets cancelled, and 1 by 1.6 into 10 power minus 19, if it is going to numerator, it becomes 10 to the power of 19. 1 by 1.6 value, if you see, it will be 0.625 into 10 power 19. Now we need to move 1 point this side, so that one point will be reduced here. It answer will be 6.25 into 10 to the power of 18 electrons constitutes in 1 coulomb of charge. Simple answer, we can write it. Next, 68th question. Electric current flows through 3 lamps when arranged in series parallel. If the filament of one bulb breaks, explain what happens to the other 2 bulbs in both cases. So they are asking case 1, 3 bulbs connected in series. So first bulb, second bulb, third bulb connected in series. Case 2, first bulb, second bulb, third bulb connected in parallel. Now what happens when one bulb, if the filament of one lamp breaks? You see, in series, if filament of one bulb breaks, remaining bulbs, I mean bulb which is present after that, will not glow. But while coming to parallel, if filament of one bulb breaks, remaining 2 bulbs will be working automatically. Normally it will work because there is no voltage drop in parallel circuit, right? In series combination, if the filament of one bulb breaks, the circuit will be broken and hence other lamps stop glowing in series. But while coming to parallel, in parallel combination of lamps, if the element of the one lamp, filament of one lamp breaks, the other 2 will continue to glow. That is the advantage of parallel combination, so that in our house also, everything, all electrical appliances connected in parallel, not in series. 69th question. Study the VI graph of resistor as shown in the figure and prepare a table showing the values of I in ampere corresponding to 4 different values of V in volt. Find the value of current for V is equal to 10 volt. How can you determine the resistance of the resistor from the graph? Okay, they have given graph. Now they have given current values as well as voltage values. And we have what we have to do, we have to see the graph and we have to take all the I values and V values, and then we have to find if V is equal to 10, what would be I value, that we have to find. Now how can you determine resistance of resistor from the graph? So it is quite simple. If you observe the graph, when, okay, here V let us take, here I let us take, when V is equal to 2 volt, I is 1 amp. V is in volt, I is in amp. When voltage increases to 4, current increases to 2. When voltage increases to 6, current also increased to 3. And when voltage is 8, current is 4. So that what is the relation means? And we know Ohm's law, V is equal to IR. From this, R is equal to V by I. Now here, V value is 2, I value is 1. Answer is 2. R value, R is equal to 2 ohm we got in this case. In this case, R is equal to 4 by 2, 2 ones, 2 twos. Here also we got answer 2 ohm. In third, R is equal to V by I. V value is 6, I value is 3, 3 ones, 3 twos. That is 2 ohm. In fourth case, R is equal to V by I. V value is 8, R value is 4, 4 ones, 4 twos. Answer is 2 ohm. In all these cases, we got 2 ohm, and hence we can write R is equal to 2 ohm. So we got resistance value, and here they asked if we find the value of current for V is equal to 10 volt. So what is the relation? 2, half of 2 is 1, half of 4 is 2, half of 6 is 3, half of 8 is 4. If voltage value is 10, half of 10 is 5. So definitely if voltage is 10 volt, current will be 5 amp. This is the answer we have to write. So at last we got I is equal to 5 amp and R is equal to 2 volt. So R is equal to 2 volt, I is equal to 5 amp. Then 70, question number 70. Find the number of electrons transferred between 2 points kept at the potential difference of 20 volt if 40 joule of, okay, given data, voltage value is equal to 20 volt. What they asked, find the number of electrons, n value is equal to question mark, transferred between 2 points kept at potential difference 20 volt, V is equal to 20 volt. If 40 joule of work or energy or heat, we'll try to see. $40 joule of work is done. Okay, W is equal to 40 joule. Then we have to find. You see, V is equal to 20, W is equal to 40, and we know power is equal to work upon time. From this, work is equal to power into time. From this, we know, you see, work is equal to power into time. We know P is equal to V into I. If you substitute, it becomes V into I into T. Again, we know I is equal to Q by T. That's the first formula what we have discussed in chapter electricity. I is equal to Q by T. Substitute. At last, we will get W is equal to V into Q by T into T. Right now, TT gets cancelled. We can eliminate time because in data, time is not given. Let us try to eliminate it. So if you eliminate after, we got W is equal to V into Q. Now from this, what is W? Work 40 joule, which is equal to how many volt? 20 volt. And what they have given in the question here, find the number of electrons transferred between 2 points kept at potential difference of 20 volt if 40 joule of. Okay. Then we have to go with the Q value. Q. So now from this, Q is equal to 40 by 20. This 20 will be going that side, 21s, 22s. At last we got Q is equal to 2 coulomb. And we need to find number of electrons. We know Q is equal to N into E. From this, N is equal to Q by E. Now Q value is 2 coulomb upon E value is charge of electron 1.6 into 10 to the power of minus 19 coulomb. Coulomb gets cancelled. We will get 2 by 1.6 multiplied with 10 to the power of minus 19. If it is going to numerator, it becomes 10 to the power of plus 19. Now 2 by 1.6 we have to solve. 2 by 1.6 multiplied with 10 divided by 10. We will get 20 by 16. 2 tens 20, 2 8s 16, 2 5s 10, 2 4s 20. Sorry, 2 4s 8. Now 4 5. That is 4 1s 4 1.0, 4 2s 8, 2 is the remainder 0.0, 4 5s 20. So at last this can be written as 1.25 into 10 to the power of plus 19. So N is equal to these many electrons. That is the answer we have to write. N is equal to 1.625 into 10 power 19 electrons. Now 71st question asked in 2014. Name and define SI unit of resistance. So SI unit of resistance is ohm and its symbol is this omega. Now how to define ohm? We know Ohm's law, V is equal to I into R. From this, R is equal to V by I. Now R is equal to V upon I. SI unit of resistance is ohm. SI unit of voltage is volt. SI unit of current is ampere. Means 1 ohm is nothing but 1 volt by 1 ampere. How can we define 1 ohm? 1 ohm is nothing but if 1 volt of potential difference applied, 1 ohm 1 volt potential difference applied across terminals when 1 ampere of current is passing through it. So here the resistance of conductor is said to be 1 ohm if a current of 1 ampere flows through it when a potential difference of 1 volt is applied. Like that we have to go. Okay, next question what they have asked. Calculate resistance of a resistor if current flowing through it is 200 milliamp when applied potential difference is 0.8 volt. Okay, here the data what they are asked. We have to find R is equal to question mark, voltage value is equal to 0.8 volt, current value they have given as 200 milliamp. 200 milli in the sense 10 to the power of minus 3. Right, now let us try to find it. We know Ohm's law, V is equal to I into R. From this, R is equal to V upon I. Now V value is 0.8 upon I value is 200 multiplied with 10 to the power of minus 3. Now this we have to solve. If you can solve this one, it becomes 0.8 into 10 to the power of minus 3. If it is going to numerator, it becomes 10 to the power of 3 upon 200. So this can be written as 0.8 into 10 to the power of 3 means 1000 upon 200. Now 0.8 into 10 is 8, 100 is 80, 1000 is 800, means 3 zeros are there. This point will be moving 1, 2, 3. So 800 by 200. 0 zeros get cancelled, 2 ones, 2 4s 8. At last we got R is equal to 4 ohm. So this is the value we got. 72nd, 72. Explain why a conductor offers resistance to the flow of current. Differentiate between conductor, resistor and resistance. Okay, when current is passed through conductor, the atoms or molecules of the conductor produce an hindrance in the path of flow of electrons. This hindrance in the path of flow of charge is called resistance. Means simply to say, consider this is conductor where there are atoms. Definitely every material is made up of atom. Consider there is one free electron. When voltage is given across terminals, this voltage will produce some force, and force is applied on the electron, free electron. Now that free electron will be in motion, it will move, it will bombard, it will collide, and it will change its direction. Again it will collide with this atom, again it will move, it collides with this atom, again it moves, it collides with this atom, again it moves like this, like that. There will be lot of collisions, hence free electron comes out. After multiple collisions it will come out. Because of multiple collisions, because of the obstacles, hindrance, because of the obstacle, it produces resistance. If there are least number of electrons, resistance will be least. If there are more number of electrons, I mean more number of atoms, there will be more collisions. If there are more collisions, there will be huge resistance. Now they ask, what is the difference between conductor, resistor and resistance? Conductor means which passes electricity, which passes charges through them very easily, nothing but conductor. Resistor means a conductor having some value of resistance. There is some characteristic for the first of all, resistor is also a small component which can resist flow of charge. So you can write definition for resistor like, resistor is a material which resists flow of charge, which resists flow of charge. And what is meant by resistance? Resistance is nothing but property of material, any conductor, any material, maybe conductor, maybe insulator, maybe alloy. It is property. If resistance is least, flow of current will be high. If resistance is high, flow of current will be least. So for which material resistance will be least means for conductors. So conductor has property of least resistance so that it can pass current so easily through them. And alloys will have huge resistance so that it can pass least amount of current and heat is generated. So like that we have to write the definitions for resistor, conductor and resistance. Question number 73. A piece of wire of resistance 6 ohm is connected to battery of 12 volt. So given data, R value is equal to 6 ohm and battery value V is equal to 12 volt. Find the amount of current flowing through it. So I value is equal to question mark. The same wire is redrawn by stretching it to double its length. Find the resistance of nu. Okay, so this is case 1. In this case 1, so let us try to find I. We know Ohm's law, V is equal to IR. From this, I is equal to V by R. V value is equal to 12, R value is equal to 6, 6, 1, 6, 2. So I is equal to 2 amp. Okay, I value we got. Now what they are asking, if the wire is stretched to double its length. Already we have seen that example. So here case 1, case 2. In case 1, R value will be this 6 ohm, 6 ohm, and the length of wire is L, area of cross section is A, resistivity rho. In case 2, R value we have to find question mark, L value is equal to stretched to 2L, A value is equal to, if wire is stretched, automatically its diameter reduces, radius reduces, area reduces, thickness reduces, it becomes A by 2 and rho value will be rho. Already we did this one. So what we can do, R is equal to rho L by A. R value is equal to 6. 6 is equal to rho L by A, means rho L by A value is 6. Now here R is equal to rho L by A, which is nothing but rho L is 2L by A is equal to A by 2. Now R is equal to rho, it becomes 4L by A. That R is equal to 4 rho L by A. Rho L by A is nothing but 6. So rho 2L by 4. So R2 is equal to this one. R2 is equal to 4 rho L by A. Rho L by A is nothing but 6, which is nothing but R1. So at last what we got? R2 is equal to 4 times R1. Now R2 value is equal to 4 into R1 value is 6. 6 4s 24. Like that we can write. So new resistance becomes 4 times greater. So you can write it as R1 is equal to, in the question they have given that is a 6 ohm. Now R2 is equal to 6 4s 24 ohm. If you need, you can write this one, or you can write this statement. New resistance becomes 4 times. Until here it is also enough. R2 is equal to 4 R1. From this they will give mark. If you want to write value, you can write this value also. R2 is equal to 24 ohm. Next, same question. A wire of length L and resistance R is stretched. Wire of length L and resistance R is stretched so that length is doubled, area of cross section is half. How resistance change? How resistivity change? Resistance definitely it will be 4R. Na? If try to remember this note, if length is doubled and area is half, then what about the new resistance? R2 is equal to what? Means new resistance becomes 4 times old resistance. It increases 4 times. R1, R2 is equal to 4R1. Just try to remember this expression, it is more than enough. Then what about resistivity? Resistivity will never change because same material we are using, same material we are stretching. If you take copper and if you stretch copper, it becomes copper only, it will never become zinc. So resistivity will not change. Here you can observe R is equal to 4R. Resistance becomes 4 times greater. And B question, resistivity does not change because it is a property of material of conductor. They are stretching the same material. So that is the concept we have to understand there. Last question in this session. In 2014 they asked, a nichrome wire has a resistance of 10 ohm. So R value is equal to 10 ohm it seems. Find the resistance of another nichrome wire whose length is 3 times, area of cross section is 4 times the first wire. Right. So case 1, case 2. Case 1, case 2 they are using same material they are using, same nichrome wire they are using. So in case 1, R value is equal to 10 ohm and L value is equal to L, A value is equal to A, rho value is equal to rho. In case 2, we don't know, R value is equal to question mark, L value is equal to, in question what they asked, find the resistance of another nichrome wire whose length is 3 times, L is equal to 3L and area of cross section is 4 times. They are not asking area of cross section is decreased 4 times. Don't get confused. Area of cross section is 4 times. So A value is 4A. Now what we can do, we can use same formula. Both cases, R is equal to rho L by A and R value is equal to 10. 10 is equal to rho value is rho, L value is L, A value is A. So rho L by A value is 10. Remember this. In second case, same formula you can use. R is equal to rho L by A. Now what is R value? We don't know. R is equal to rho value is rho. Why? Because they are using same nichrome wire. So R value is R and L value is 3L now upon A value is 4A. Now what can be done this one? This can be written as R is equal to, you can take this 3 separate numerator, 4 separate in denominator. It becomes 3 by 4 rho L by A. We know rho L by A value is 10, right? So what we can do, R is equal to 3 by 4 multiplied with rho L by A value is 10. You can place 10 here. 2 2s 4, 2 5s 10. Now R is equal to 5 3s 15 upon 2. So 15 upon 2, what is half of 15, which is nothing but 7.5. Let us see here. So maximum we should not leave answers in this P by Q form. So R is equal to 15 by 2 is nothing but 7.5 ohm. So this is the final value we have to write. And we will see remaining questions in the next lecture. We will try to complete all 3 marks questions, and then we'll move to 5 mark questions. That's it in this lecture.